Hi, we're going to be working on Unit 2, Lesson 5. This is compound interest and irrational E. So what does it mean to earn compound interest on an investment? Basically, it means that you are getting interest on everything that's in your bank account each month or quarterly, depending on how they do it. If you were doing simple interest, you would be only getting interest on your whatever your initial amount in the bank was. Even though it's growing over time, you're still only getting the interest on what was originally there. Okay. Now, this is compound interest. So here, A equals amount of money at any time, at a specific, oh goodness, Cami likes to play around every time, right? Amount of money at a given time. P is your principal amount. Okay, principal meaning your starting amount. Okay. R is your interest rate. And we want this as a decimal. So if you're given it as a percent, you're going to divide it by 100, or you're going to move your decimals 2 places to the left. End is the number of compounding periods or time. So if we're doing it quarterly, we're doing it 4 times a year. Weekly, so every week. And if we were doing it daily, things like that. Compounding periods. Now T is time in years. All right. So starting off with a problem. So if you were wrong, you're young and you haven't saved much money yet. As a matter of fact, you only have $100, but you really want to make the best of it. So you have $100. That is your P for principal. So we're going to be writing the equation, but we need to read a little bit more. So we have a savings account that pays a generous 5%. So what we're going to do is we're going to change that 5% to 0.05. We're just moving the decimal over 2 places. That is your R. And it's compounded only once per year. So that's your N is going to be only once. How much money would it make at the end of the year? Okay, so first we're going to write our equation with everything and then we'll solve it. So we have A equals our principal, which is $100. And we have 1 plus our rate over the compound periods, your N, and then we're going to take it 1t, or just t if you would like. Now we're going to do this, how much would be at the end of year 1? So at the end of year 1, how much money would you have? So that means t is going to equal 1. So we're going to put this into the calculator. Whoops. I'm so used to saying y, sorry. We're going to go A equals 100, 1 plus 0.05 over 1, basically to the 1 times 1. And if you put it in the calculator, at the end of the first year, you're going to have $105. Not much, but it's a good start. Now the next one, we're going to do it at the end of 20 years. So that's your new T. So again, we're going to do our formula. Oops. Sorry about that. Fun part of the computer. A equals 100, 1 plus 0.05 over 1, and it would just be 20. And 1 times 20 is just 20. You're going to put this into the calculator, and at the end of 20 years. And this, you're going to have $265.33. And this is if you are never going to touch that money. So you didn't add any more money, you didn't take out any money, you just put the money in and left it alone, which is not something that we usually would do, but it would happen. Okay. Now it seems like the more compounding periods in the year, the more money you should make. The question is, does it really make a difference? So what you're going to look at is the table on the right, and this one is what would happen if you compounded the amount of money you would have after 20 years, if you compounded twice a year, so semi-annually. So here is what we got if we only did it once per year. 2 twice a year, semi-annually, 4 times a year, quarterly, 12 times each per year, so monthly. Then it would be daily, then hourly, and so on. And what do you seem to notice? The thing I notice is the more you do it, it doesn't really seem to change very much. It's going to still stay to be 271.8 something. Now, the nice thing is, it turns out that if you even do it 100 times, it actually becomes a very famous irrational number named E. Because E is irrational, it is non-terminal, non-repeating decimal, very much like pi. And then there are the first few digits of E. Like pi, E is a number that occurs in mathematics of many real-world situations. This includes exponential growth. One of the formulas using E results from the thinking that you just did, with thinking about what you just did, the compound interest. But what if it was compounded continuously? If it is, this is the equation we're going to have. Now, P, again, is principal, the same amount of money. The R is your rate, and you're going to want to make sure you change it to a decimal. And the way I remember it is the percent sign has 2 zeros, so you're moving it 2 places to the left, or divide it by 100, which also has 2 zeros. Okay, the next thing is T. All right, so here we're going to go, and we're going to do 2 different problems. So I'm going to do it 2 problems. So it is fairly typical for savings accounts to be compounded monthly. Compare the amount of money in 2 savings accounts after 10 years. So we're doing it 10 years with the same initial amount of $500. So that's your P. This is your T. Your interest rate, and if we do it, it's going to be 0.03. That's your R. The first one is going to be compounded monthly, like we did on the previous problems. And the second one is going to be with the E, which is compounded continuously. All right, so the first one we're going to do is if it's compounded monthly. So monthly, that's your N. Remember, N is going to be 12 because it's every month. So we're going to go 500, the initial amount, 1 plus our rate over 12. And then we're going to raise it to our N value times our number of years. And you put it into the calculator, and you get this amount of money, $674.68. Not too bad. That's if you just left it alone and didn't put any extra money. Now the next one is we're going to use that E value. So when you're using it on the calculator, you have to be very careful. If you do E, sometimes you have to do a second button or a shift button, or on you can do it on Desmos and just type in E. It will know what you're talking about. So here we're going to take A equals, A means the final amount, is going to take our initial amount times it E to the rate of 0.03 times are 10 years. And if we put that straight into the calculator, we're going to get 674 and 93 cents. So very, very close in amount. It's just a couple cents more, less than 30 cents more as difference. That's pretty neat. Okay. So pretty interesting if you did it this way. Okay, so we're going to use technology and we're going to compare the two graphs. So let me get those. All right. I'm going to bring in, and this will show in just a minute. Okay, that's for another problem. Okay, so what we're going to do is our first problem. So A equals, or we can do Y equals because we know that, 500, 1 plus 0.03 over 12. And we're going to raise it to the rate, our compounding annually, and we'll get that. And I'll show you in just a minute. And then the second one, we're going to go Y equals, bring this over, get that second equation. And I'm just putting in X for our T value because it just graphs a lot easier. Helps if I'm actually on it. 500E, raise it to the 0.03, and then X. And then I'm going to adjust it. I'm going to start off at 0. Let's go 20 years. And our Y values, we know we're going to start at 500. And we know it will go up to, in 10 years, it'll go up to 600. Let's just say 700, just to see what it would look like. All right. So here we can see that is our compounded monthly. And if we look at our other one, it's compounded continuously. Our equation is very much the same. Very close to it. So it is going to be about the same. Okay, the next one, it says, so could we conclude? We can conclude that both equations are going to be pretty accurate. Now, the next one we want to do is we're going to graph e to the x on Desmos, and we're going to draw a sketch. Okay, so here we have e to the x on Desmos, and I just like having a little chart or a little table, makes it a lot easier. So what if you ever want to do a table, let me go ahead and delete that one and I'll show you. You go up to the little gear sign, go over to table, and it gives you it. And you can even add more numbers. You can even make your own number. So if I said 10, you can see what it's going to be, but that's way too high. All right. And neat thing, if you click on this little magnifying glass, it's supposed to zoom it in so you can actually see what it looks like. And that's what we're going to do. Oops, need to move it over. Okay, it's going to be crossing at 0, 1, and then it's going to, if I do it this way, it's going to keep cross at 1, and it's going to keep going up. And we know for sure one of our points is 0, 1. It is continuing over the entire domain. And which one is this similar to? Which graph? Isn't this similar to our exponential and our logs? So very, very similar to even y equals 2 to the x. Very, very similar to this. All right. Once you're finished taking your notes, you're going to be working on your assignment for today, which you can find on your device, either Google Classroom or Canvas.